All right, so this is the second half of our midterm review. All right, so number 12, a rocket is launched from a platform 3 feet off the ground. The path of the rocket is a parabola described by the equations h of t equals negative 16t squared plus 60t plus 3, where h is the height in feet and t is the time in seconds. So A, how high is the rocket after 1 second? So when we're asked how high something is after a certain amount of time, this is just plug and chug. All right, so we're just plugging 1 in for t. So negative 16, 1 squared plus 60 times 1 plus 3. So when you do that on your calculator, you would end up with 47 feet. Okay, if you're not getting that on your calculator, be careful. Make sure you have negatives where you need to, different things like that. All right, part B, what is the maximum height of the rocket? So when the rocket launches and goes up and comes down, the highest point is going to be right here at its vertex, right? So our vertex, instead of being xy, it's th, right? So this is replacing, t is replacing the x, h is replacing the y. So to find the vertex, to find the x, we do negative b over 2a. To find the y, we plug and chug that answer that we got for x, okay? So I'm going to start with my negative b over 2a. So this is going to be negative 60 over 2 times negative 16. Make sure you put it in your calculator just like that too. All right, so this is going to end up giving me 1.875 seconds, okay? So that's how long it takes for the rocket to get to its maximum height, but we want to know what the actual maximum height is. So we're going to take this, the time, and we're going to plug that back into our equation. So negative 16 times 1.875 squared plus 60 times 1.875 plus 3. When you put all of that into your calculator, you end up with 59.25 feet. So its maximum height is almost at 60, so 59.25. All right, part C, how long in seconds will it take the rocket to get to its highest point? Well, we've already done this, right? To get to the highest point, that's the x-coordinate of our vertex, and to find that, it's negative b over 2a, which we already have done up here, so it's 1.875 seconds. How long will it take for the rocket to come back and hit the ground? So this is where we have to do our quadratic formula. Okay, so we start with our b squared minus 4ac. So my b is 60 squared minus 4 times negative 16 times 1. So when we do that, we end up with 3792, so 3,792. So we're going to plug that into our quadratic formula. So negative b plus or minus square root of 3792 all over 2 times my a value, which is negative 16. All right, now, normally we would go and we would simplify this, but we aren't going to do that in this case. So in this case, we are just going to simply, we're going to use our calculator to figure this out. All right, so I have to do, remember we have two different answers here, the plus version and the minus version. So I'm going to start with the top of the fraction here. So I have negative 60 plus square root of 3792. Then I'm going to divide that by 2 times negative 16. And that gives me this negative 0.04935, blah, blah, blah. Does negative time make sense? No, it does not. So then we have to do the minus version. So we've got negative 60 minus the square root of 3792. All of that divided by 2 times negative 16. And that gives us 3.79935. So about 3.8 seconds for the rocket to come back and hit the ground. Okay? All right, number 13, function, not a function. Number 13 is a function because we don't have any x values repeating. We don't have multiple lines coming from one of the x's. Number 14 is not a function because right here, number 5 here goes to 2 different ones. So that means your x is repeating. Number 15, do the vertical line test. Notice that it hits it twice. So this is not a function. All right, number 16, label the graphs with absolute max, min, or relative max or min. Okay, so for A here, so notice both arrows point up. So that means I'm going to have an absolute. And in this case, since both arrows are going up, I'm going to have an absolute min. Okay, so A, this is not the lowest point. C is actually the lowest point. So this is going to be a relative min. B is a relative max. And C is going to be our absolute minimum. Okay? 17. All right, we got lots of letters here. A, B, C, D, E, and F. Now, notice arrows go in both directions. So that means this graph extends forever down and forever up. So that means none of these points are going to be absolute because there's going to be a point that goes above or below it if the graph were to keep going. Okay, so all of these are going to be relatives. And then we just need to determine min or max. So obviously A is going to be a max, B is a min, C is a max, D is a min, E is a max, and F is a min, right? Because it's a low point, that's a high point, so on and so forth, okay? All right, number 18, find the end behavior for number 16. So as x goes to negative infinity, that's meaning the left-hand side. So the left arrow, it's going up, so that's going to positive infinity. As x goes to positive infinity, we're talking about the right-hand side. That also goes up, so that's also positive infinity. Number 19. Okay, so remember, to find end behavior from an equation, we're looking at leading coefficient and our degree. So our leading coefficient is negative, so that means the right-hand side goes down automatically. This is odd, so that means these two are going to be opposites. Odd, opposites, even, the same, okay? All right, and then evaluate functions down here at the bottom. All right, so all you're doing is plugging in the stuff that they tell you for x. So it says find f of negative 2 if f of x equals this. So all I'm going to do is take negative 2 and I'm going to put that in for every x that I see. So 3, negative 2 squared, plus 4 times negative 2, plus 2. So we start with my exponents. Negative 2 squared is 4. 4 times 3 gives me 12. 4 times negative 2 gives me negative 8, plus 2. 4 minus 8 is 4, plus 2 gives me 6. All right, number 21. Now we're getting an expression. Okay, so I'm going to plug in the expression into wherever I see an x. So 2x plus 1 and then minus 2. That's what this is. So I'm going to start inside the parentheses, right? So I have a positive 1 minus 2. So that's going to be a minus 1. Now I can do distributive property, 8x minus 4. And that's it. That's all I can do with that one. So since we're given an expression, notice my answer is an expression. Okay? All right, and then finally number 22. Okay, we're going to plug in x plus 7 for any x that we see. So we have x plus 7 squared plus 2 times x plus 7 minus 1. Okay, so I'm going to start with this first. So this is going to be FOIL, first, outer, inner, last, right? So x times x gives me x squared. X times 7 is 7x. 7x, 49. Combine the two middle terms, so I have x squared plus 14x plus 49. That's great, but that's not your final answer, okay? The reason that's not your final answer is because you only did this part right here. We still need to do all of this. So we're going to do our distributive property here. So 2x, so plus 2x. And then 2 times 7 gives me 14. And then I have a minus 1 on the end. Last step is then to combine like terms, okay? So I only have one x squared term, so we're good there. I have 14x and 2x. So that's going to give me 16x. And then I have a positive 49, positive 14, minus 1. So when I do all that together, that's going to give me a positive 62. So plus 62. And that is your answer. Okay? If you're still confused on something, please don't hesitate to reach out to me, and I'll be happy to help you guys. Happy studying.